In this video, we are going to discuss how to use Wolfram Alpha to perform integration. Wolfram Alpha is a very powerful online service that allows you to perform many tasks in calculus. Wolfram Alpha is sort of an online version of the software package called Mathematica, which is a software produced by the same company, Wolfram. But there are some differences between the Mathematica software and the online version Wolfram Alpha. The main difference being that the online version Wolfram Alpha is not requiring strict syntax. What I mean is that Wolfram Alpha can be used without the need to go through the steep learning curve of how to define the syntax or design the syntax as required by the Mathematica software. As I will demonstrate to you later on, you can use various flexible ways to define the integration into Wolfram Alpha. You will find that even you are using different non-standard method to input the instructions into Wolfram Alpha, you will still obtain an output from the Wolfram Alpha. Therefore, in this sense, Wolfram Alpha is much more flexible when it comes to providing the instructions to carry out the operations that you need. The first thing you will do is to follow the prompt as shown on the screen to land on the Wolfram Alpha webpage. To begin with the first applications of Wolfram Alpha, let us try to reproduce the analytical result of the integrations we have discussed in example 1, module 1. Here, you have to tell Wolfram Alpha that you are going to make an integration. Navigate your mouse to the symbol representing del integrate. Then you will be seeing a list of icons. Choose the integral icon. You will see a placeholder representing an integrand and a variable. Move your mouse to the integrand placeholder to define the integrand function. Here the integrand function is a fraction function, so you need a fraction symbol. Navigate your mouse to the symbol of a square root. Click on it. You see the fraction symbol. Click on it. You generate a fraction. For you to key in the numerator, type 2x minus 9. Move your mouse to the denominator and define the square root symbol by pressing on the square root icon. Define x squared. To define the square, you have to use the square icon. Click on it. You generate a base raised to the power of 2. The base is x, so you have x squared. Press the right arrow key on your keyboard, minus 9x plus 1. Then move your mouse to here, the first variable placeholder, press x. That completes the definitions of the integration to be carried out. To obtain the results of this integration, navigate your mouse to the equal sign. Click this equal sign icon. Wait for a few seconds. If your Wolfram Alpha is online, you'll be able to obtain the result as expressed in the indefinite integral output as displayed here. And these results by the Wolfram Alpha is exactly the same as the one produced in example 1 using analytical approach of substitution. Wolfram Alpha not only gives you the results of the integral, it also gives you the plots of the integral for two different range of x. Here is the plots for the integral results from minus 9.2 to 11.2. It also gives you the plots for the integral functions from minus 91 to 100.3. It also gives you an alternative form of the integral. You make sure that the left-hand side in the indefinite integral output is exactly as what you have instructed the Wolfram Alpha to do. The left-hand side in the output of Wolfram Alpha is a result of the interpretations of what you key in. If your input that you key in is wrong or wrongly interpreted, then the expressions of the left-hand side in this indefinite integral output will reflect that incorrect fact. Let's move on to another example. Here we would want to ask the Wolfram alpha to produce the result of the integrations of secant x plus tangent x raised to the power of 2. Here I would like to demonstrate a shortcut. Instead of using the icon, I would want to use my keypad as the main instrument for providing the instructions to Wolfram alpha. The instructions of performing integrations in Wolfram alpha can be done by typing in the word integrate with a left square bracket followed by a right square bracket, which allows you to generate the integral sign. To define the square of the integrand, I first key in open and close bracket raised to a power of 2. To key in the symbol of power of 2, simply press Shift caret key. That will generate a power placeholder where you type in 2 for the power 2. Then navigate the prompt using the left key on your keypad, SCC and a bracket of x, then define the function of secant x in Wolfram alpha. Then use your right arrow key, press add symbol, followed by tangent and a bracket, and key in x in the bracket of tangent. That specifies the integrand function, and you need to also tell Wolfram alpha the symbol of your variable, which is x. That would be the instruction for performing an indefinite integration. In order to run the calculations, press Shift Enter and wait for a few seconds. If the input instructions is correct or correctly interpreted by Wolfram alpha, the interpretations will appear on the left hand side in the indefinite integral output panel. And the results that is given out by Wolfram alpha is as shown on the screen. And if you compare this expression to the expressions on the left hand side in the PowerPoint slides of example 3, where the integration was carried out using analytical method, the two results are actually the same, except that in Wolfram alpha, the output of this term is arctangent of tangent x, which should be interpreted as minus x. In this sense, the output of Wolfram alpha is considered not as perfect because this should be expressed as arctangent of tangent x should be just an x. But somehow Wolfram alpha does not show or simplify these expressions into x. Apart from this minor imperfection, the analytical results obtained from Wolfram alpha match with what we expected. As a conclusion to this video, we have provided some preliminary introduction to what Wolfram alpha is and how to use it to reproduce the results that we obtained for example 3 and example 1 that we have discussed in module 1. We will continue to demonstrate the reproductions of the analytical solution to the integrations examples in the next few videos.